Good morning, students. I welcome all the students of Standard 8 to the online classes in science. Today we would begin chapter named as friction. But before I discuss anything, students, I would like you to observe one simple activity and then think what could be its cause. I have two textbooks. In your home, you can take any two notebooks or any two books. What I will do, one by one, I will overturn their pages and I'll make them interlock or overlap like see. One page of this book, one page of this book, next page of this first book, the next page of second book. Like this, you go on doing. Actually, if you do page by page, it will be better. But to save some time, I am doing it quickly. So is it clear what I am doing? Just I am interleaving the pages of one book within the pages of other book. I told you we have to do it one by one, but I am doing some pages at a time. So let's see what do we get. It will take some time, but then after you are done, you will find something very amazing. So I am now doing it quite quickly. Okay. This is sufficient, I think. We are done. Let's see now what we have got. These two books whose pages I have interleaved, now if I try to separate them, believe me students, I am applying large amount of force, but I am not able to separate them. Why is this happening so? You can see students, those two books, I will not give any support to the second one. I am just holding this, but it doesn't fall down to make you believe that they have binded together very hard. Even if I try to pull, I am not able to separate the books. The only way I can do that without tearing the books is to reverse the process what we have done. That means what you have to do, you have to open the pages one by one like this, and then you have to continue that process in the reverse fashion, and after some time you will be successful in opening the two books. So this was a small activity. I'll come to this activity after some time. Now before starting this chapter of friction, in the last chapter you have read about force. You have also read about effects of force. One of the effects of force is that it can accelerate. What is the meaning of accelerate? It can change the speed of a moving object. This you know, student, that is one of the effects of force. There are other effects of force, but I will not discuss that. If a force acts on a moving object, it will change its speed if it is moving in a straight path. So suppose there is an object which is moving in a straight path like this, and if there is a force acting on this object in this particular direction, force I will represent as F. Force is acting towards right, so in right direction its speed increases. But if a force is acting in a direction opposite to the direction of its motion, motion is towards right, force is towards left, then you know what will happen, the speed of the object will decrease. So speed of an object can increase or decrease depending upon the direction of a force. Now if I ask students that if no force acts on the body, that means F is equal to 0. In this case, what will happen to this speed of the body? Will it increase Will it decrease or will it remain same? So students, you can guess, if there is no force on the body, its speed will become constant. It will not increase, it will not decrease. This is a very important result which you should remember, that if a body is moving in a straight path with constant speed, then it means no net force is acting on the body. Is it clear? So this statement I have written, what I have explained just now, that if there is a body which moves in a straight path with a constant speed, then the net force acting on the body will be how much? It will be 0. The converse is also true. If net force on a body is 0, then if net force on the moving body is 0, then it must have a constant speed. Its speed will change only if there is some force acting on the body. There is some non-zero net force acting on the body. Okay, let us now proceed further. Suppose there be a situation like this. There is a straight path. On that path, an object is moving with some speed in this direction towards right. Suppose two forces are acting, F1 and F2. Both these forces have same value, that is 20 N. What does N stand for? It stands for Newton. Newton is the SI unit for force. Just as we use kilogram for mass of a body is 20 kilogram, for example, we say 1 kilogram. So kilogram is the unit for mass. Likewise, the standard unit for force we take as Newton. Now, you have in last chapter read about balanced and unbalanced forces. These two forces are balanced. Why they are balanced? Because they are equal in magnitude, 20 and 20, and they are in opposite direction. Opposite direction means they will cancel each other. If there is a body like this, one boy pulls this body towards right, other boy pulls this body towards left with same force, then this body neither goes towards him nor towards him. It remains at its own position. Why? Because we say these two forces are balanced forces, they will cancel each other. So net force in this case will be how much? 0. See, there are two forces, but net force is how much? 0. And since net force is 0, based on the discussion which I have discussed with you just before this, we can conclude that speed of the body must be constant. So in this situation also the body will move in a with a constant speed. Okay. Next, students, please concentrate over this particular situation. There is a plane surface. On this plane surface there is some object which I am placing it like this, and I will apply some force on this object to move it, and I will apply a force in that direction. You see, and I will try to apply a constant force like this. So I am applying a force because of which it is moving, and you can see its speed is not increasing, it is remaining almost constant. Let me repeat it again. I am applying some force. Let me, for the sake of simplicity, say that my force is suppose 2 Newton. How much? 2 Newton. So I am applying 2 Newton force with my finger in that direction, that is towards right. Because of that force this is moving, but you also find that its speed is not increasing. Is this situation clear? Okay. Now tell me, students, was the speed constant? Yes. If speed was constant, what should be the net force on the body? We have discussed it should be 0. How much force I was applying? I was applying a force of 2 Newton in that direction. But I am saying since the speed was constant, net force must be 0. That means there must be balanced force. Who is balancing my force? Which agent is balancing my force? This is the question. That is the clue for the topic is our clue, that agent is the frictional force. So when I apply a force of 2 Newton in right direction and I find that this body is moving with constant speed, it means there must be a force in opposite direction. That force is acting between its base of this object and this plane. So between these objects there is a force of friction which is acting in a direction opposite to the applied force. This finger is applying the force, so this is the applied force. Applied force is towards right, and its value is how much? 2 Newton. Frictional force between these two bodies is acting towards left, and its value will also be how much? 2 Newton. So this is a force. First thing that you have to understand, students. Why there is a frictional force? How does it arise? That we will discuss afterwards. But for the time being, you remember friction is also one kind of force. It is this force which opposes the relative motion between two bodies. So while playing football, when you kick the ball, or while playing cricket, when batsman hits the ball rolls, the ball moves on the ground, it rolls to some distance, and then after that it stops. That means if it is stopping, that means the velocity of the ball is changing. Who is responsible for the changing velocity? It is the frictional force between the ball and the ground. So just now what we have discussed, I have shown you that if there is a body which is sliding over another surface with constant speed due to some applied force F, then since it is moving with constant speed, the total net force must be 0. So opposite to the direction of applied force, force of friction acts. This force of friction has same magnitude. I'll represent like this, and the force of friction I'll represent by small f. So this is what? This is frictional force, which we also call as friction. The example which I have discussed, where the body was moving with constant speed, there I can say that the force of friction F and the applied force capital F, they are equal in magnitude and opposite in direction. So F and F, they are opposite in direction and they have same magnitude. Let's see one more situation. Suppose I apply very small amount of force on this body towards right, like with my finger, like this, such that this body should remain at rest, it should not move. But I am applying a force. You might say, sir, you are not applying a force. But you don't, because you don't feel that. But believe me, I am applying a small amount of force. You can imagine that suppose you are trying to push a heavy table in your home. So I am applying, but the table is not moving. Likewise, this object is suppose not moving, but I am applying some amount of force. Since it is not moving, that means its velocity is always 0. Since its velocity is always 0, it means net force on it must be 0. And if net force on it is 0, I am applying a force, suppose 0.5 Newton in that direction, there must be a force in opposite direction. And what is that force in opposite direction? That is nothing but friction. Similar thing you can experience in your home. I suggest all of you do this activity in your home. If you have a heavy, you can have a bed or a table or something like that in your home. First try to push it gently. You will find you are applying some force. So I am applying a force in that direction, that means towards left. So this is applied force. Initially the table does not move. That means the table is at rest. How is it possible? Because if it is at rest, total force must be 0. Now who is counterbalancing this particular force? This force is being counterbalanced by frictional force. Can you guess, student, where is the frictional force acting? Frictional force always acts between two objects between which there is relative motion, between which there is a tendency to slide. Here the legs of the table, they tend to slide on the floor, this is the floor, towards right, because there is an applied force. Since it tends to move towards right, the frictional force will oppose, so these legs will experience a frictional force in opposite direction at 4 places, and their combined effect I am writing as small f. What is small f? Small f is the frictional force. So I have discussed 2 examples. Third possibility is there. So in A I had discussed body moving at constant speed. Second, I have discussed body at rest. And in third case, there might be a body which is moving with changing speed. In that case also there will be friction. Now it's important to note what is the direction of friction. You see, in first case, where was the body moving? The body was moving towards right. So this body is sliding towards right with respect to the ground. Friction is opposite to that. Friction is towards left bit on this body. This table, because of the applied force F, had a tendency, it is not moving, but it appears as if it will move in this direction, but it is not moving. So it has an impending motion towards left, but it is at rest. Even then, the frictional force is acting in opposite direction of impending motion. So what I mean that friction force always acts in a direction opposite to the direction of actual motion or impending motion. That will give us the direction of frictional force. So whenever an object moves or tends to move in a particular direction, suppose there is the body which is at a rest, then you try to think in which direction it has a tendency to move. For example, this table has a tendency to move towards left, then frictional force will be towards right. So this is a very important parameter, students, that frictional force always tries to oppose relative motion between two bodies. This frictional force is opposing the motion of table on the floor. This frictional force is opposing the motion of this block on the ground, and so on. So now we are ready to discuss the definition for friction. See, in different texts you can find different languages. I suggest you students to understand the concept and write the definition in your own words. Wherever possible, use your own language. Technical terms should be there. You should not miss anything, but the formation of sentences you can do yourself. Now you have reached to standard 8, you should develop this particular habit. Don't try to memorize these definitions. In your textbooks you have a definition, and believe me, you can write a definition better than what I have written. Clear? So frictional force may be defined as the force that arises between two surfaces in contact when one surface moves or tends to move relative to the other surface. Suppose this is one surface and this is second surface. One surface when over another surface are placed in contact, and if it tries to slip or move over another surface, either this surface tries to move or the lower surface tries to move. In both the cases there is relative motion between them. In such cases, the force that arises between these two surfaces, that force we call it as frictional force. And we have written one statement that the friction always opposes relative motion, whether it is actual or impending. Impending means, students, which is not actually happening. The way I discussed in case of table you are applying a force but it is not moving. But if it would move in the direction of applied force. That is the meaning of impending motion. If there is actual motion or there is impending relative motion, in both the cases friction will always be opposing the actual or impending relative motion between two surfaces. So this is the meaning of frictional force. Any two bodies, there will be friction. There is friction between this board and my palm. There is friction between the tip of this pen and this board. There is friction between this pen and my palm. Any two surfaces, when they are in contact and are trying to slide over one another, there will be friction between them, such that the friction opposes the relative motion between the two surfaces. Now let me discuss what are the factors on which friction depends. See, I have not discussed still the cause of a friction, that I will discuss in the next class. Today I would devote some time in discussing factors on which friction depends. Two factors I have written on the board. The first factor is the important one, that friction between two surfaces will depend upon the nature of those surfaces. Different types of surfaces, they will offer different amount of friction. Let's see one example. So I have a plane like this. Two objects I'll put. There is a speaker. You can choose any two objects. You can put eraser, you can put sharpener, you can put a notebook over this. Whatever things, I would suggest you to put different types of objects on such a plane and then repeat this activity which I am doing. This is a horizontal line. First put this plane along this horizontal line. On this plane I have put 2 objects. If you want, you can put 4 objects, 5 objects, you can try it. Now these 2 objects are put side by side. Now I will try to increase the inclination. This is horizontal. Now I will try to increase the inclination and let's see what happens. From one side I am lifting it up. You can see the mobile phone has started sleeping. Could you see? But the speaker has not yet started sleeping. What does this activity suggest? In which of the 2 cases, mobile phone or this speaker, the friction is more? Of course, in this case, since friction was more between this board and this speaker, that's why there was more opposition to its motion. If there is more friction, then its motion will be opposed more. So please see it again. You can see the mobile phone slides, but at that angle this speaker is not sliding. Let's increase the angle further. Now it has started sliding. So likewise, you can choose different pairs of objects, students, and you can verify between which pair the friction is more and between which pair the friction is less. So that is a very important lesson to understand. Friction will depend upon what kind of materials you are using. That is factor number 1, nature of the surfaces or materials. Second one is force pressing the 2 surfaces together. Suppose in this particular example of mobile phone or any one object put over a plane, it starts slipping at this particular angle. Clear? Now what you do, you put something heavy over this, like this, or you can ask your brother or sister or parents to apply a little force on this. If you apply little force on this, little force, not very large force, then you will find that it will not slide easily. Let me put it like this. Even if you increase the angle to such a large value, it is not sliding. Now it started sliding. Again apply more force, it will not slide. If you apply this force, what is happening? There is more force pressing the 2 surfaces. Which are the 2 surfaces? One is this one, second one is this one. So these 2 surfaces, if they press hard, the friction will be more. Is it clear, students? And based on this, let me tell you one more example. Suppose I ask you to rest a copy or a object, any object, I am taking a cardboard, onto the wall. On your wall, suppose you put it like this and leave it. What will happen? It will fall down. But if I ask you to do an activity wherein you have to put it against a wall such that it should not fall, then what you will do? You will apply a force like this. Understand the physics behind this, students. Gravity is pulling it down, and who is pulling it upward? The net force is balanced because it is at rest. If gravity is in downward direction, there must be a force in upward direction. Do you know what is that force? That force is the frictional force between this board and this surface. And that frictional force was initially less than gravity, that's why it fell down. But when you exert some force with your finger onto this board, then the frictional force increases because of second factor, force pressing the 2 surfaces together. So when you apply a force like this force pressing these 2 surfaces together increases the frictional force. And in which direction frictional force is acting? In upward direction. That frictional force increases and becomes equal to the gravity. That's why it does not move downward. The moment you remove your finger, the force pressing these 2 surfaces also gets vanished. And in that case, the frictional force gets, it drops to a very less value, almost a 0. and therefore the object falls under the influence of gravity. Please try to think of many activities that can explain friction in the fashion I have told. Students, today I'll stop here. So today what we discussed an introductory idea regarding what is the meaning of friction. We discussed that friction will always act between two surfaces in contact whenever there is relative motion or impending relative motion between two surfaces. Then we have discussed what are the factors affecting friction. There are two factors. One is nature of the surfaces in contact, and second one is the force pressing the two surfaces together. Now, before concluding, let me remind you about the activity which I did in the beginning. So when two books I had taken and I had overlapped them page by page, I still have that particular arrangement, this one. So what happens, one page over other page, then third page, then this page, then this page, then this page. When you do like this and it gets piled up, then between each pair of pages, suppose this is one page, this is one surface, this is other surface. So these two surfaces, there is friction between them. So when we try to pull, the friction between them opposes our force. Now between two pages, one pair of pages, the friction is not sufficient. If you take one page and if you take another page, put them together, and if you try to pull the two pages away from each other, you can easily do it. But here the number of pages are large number of pages have been interlocked. Because of that, the friction between one pair, then next pair, then next pair, then next pair, then next pair, so many pairs are there that results in addition of all those frictional forces, and the total frictional force becomes so very large that even on applying large amount of force, please, while doing this activity at your home, I strongly recommend you not to pull very hard. Not because the books will get separated, but because your books will get torn. So the only option to again use this book properly is to open the book pages like this, reverse the process. Clear? So it was simple activity, and such activities, students, it will make you more interested towards this particular subject of physics, and you will realize that physics is actually fun. All the best, students, read well. And regarding notes, whatever you see on the board, whatever I speak, try to have the habit of making your own notes in your notebook. So you must be having classwork notebook. In classwork notebook, write all those things which I have discussed today. Make your notes yourself. Whenever possible, I'll be discussing and I'll be giving some PDF also. But today, whatever I have discussed, you make the notes yourself. Read well, students. Take very good care of yourself. All the very best. See you in the next class. Thank you.